All right, we have here our notes for rationalizing denominators, complex numbers, and radical equations. I'm going to go through the examples that are found in your guided notes, and then I will work them out so you can take a look at those. This is again for Math 026, and it's the online class. All right, the first thing we're going to look at is rationalizing a denominator. Again, just like with negative exponents, in math, you're not allowed to keep a negative exponent unless it's in something like scientific notation. Another rule with math is that they don't like radicals in your denominator. If you have a radical in your denominator, what you need to do is rationalize that denominator, which means remove the radical from the denominator. So we're going to start off with a, where it's the square root of 6 divided by the square root of 2. Now, a radical in the numerator is okay, but we need to get rid of that radical in the denominator. So what we're going to do is, in order to rationalize the denominator or get rid of the square root of 2, we are going to multiply the bottom, not by 2, but by the square root of 2. Because remember, in order to multiply radicals, you have to have the same index, and they both have to be underneath the radical. But again, with fractions, if I do something to the bottom, I also have to do the same thing to the top. What this will give me when I multiply will be the square root of 12 over the square root of 4. But we know that the square root of 4 simplifies to 2. So we got rid of the radical on the bottom. Now the square root of 12, it's not a perfect square, but it does have a factor that is a perfect square. So we do need to simplify the expression. And remember from our last section, 4 times 3 gives me 12, so we can do the square root of 4 times the square root of 3, which will end up being 2 square root 3. And that's my final answer. We have 2 square root 3 over 2. All right, let's take a look at B. Now, right now, it's written as one radical with a fraction underneath the radical. In order to solve this, we're going to separate it. We're going to make it into 2 radicals, one on the numerator, one on the denominator. So we have the square root of 49 over the square root of x here. And the nice thing is, the square root of 49 we already know equals 7. So we're going to get rid of that radical, and we're just left with the one on the bottom. To simplify the bottom, we need to get rid of the square root of x. Again, to get rid of something, it's the same thing. You're going to multiply by the radical in the denominator. So to get rid of the square root of x, I'm going to multiply both the top and the bottom by the square root of x. And what is going to happen is when I simplify, I'll have 7 square root x over the square root of x squared. But we know from simplifying in the last section, again, that the square root of x squared is x. And on the top, there's really nothing that we can do to simplify. So our final answer is 7 square root x over x. Okay, and our last one is C. And we have here 4 over the square root of 8b. The top, there's no radical, so we don't have to worry about doing any simplifying there right now. But to get rid of that square root of 8b on the bottom, we're going to multiply both the top and the bottom by the square root of 8b. So that will get rid of it. So what's going to happen is on the top we'll have 4 square root 8b. And on the bottom we'll have the square root of 64b squared. Again, when we simplify on the bottom, the square root of 64 is 8. The square root of b squared is b. So we have just 8b on the bottom. On the top right now, we have 4 square root 8b. But 8 has a factor of 4 in it, which is a perfect square. So we have to simplify. So we're going to have 4 times the square root of 4 times the square root of 2b, because 2 times 4 is 8, all over 8b. Okay, the square root of 4 is 2. So 4 times 2 times the square root of 2b is going to give me 8 square root 2b all over, and that's a b there, all over 8b. All right, and I'm going to write this, and I'm kind of running out of room up here. Right now, this is what we have. We have 8 square root 2b over 8b. Okay. There is one final thing that we can do. I have 8 over 8, which equals a 1. So this can be simplified. It equals a 1. They cancel each other out, kind of. They equal a 1. So my final answer is going to be the square root of 2b over b. Okay, here we go with our next example. This is 1 over the cubed root of 2. Now, with your cubed roots, it's a little bit different. I can't just multiply it by the cubed root of 2 again, because it'll give me the cubed root. So if I multiplied this by the cubed root of 2, it would give me the cubed root of 4, which is not a perfect cube. It doesn't simplify. So I can't do that, but I have to think about my perfect cubes. And again, this is where like that list we made in the other section came in handy. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. I don't think we'll need to go higher than that. So what I want to do, let me go ahead and just erase that since it's wrong, okay, is I want to make it into, in this case, our 2, the closest cubed root is 8. So I'm going to make it into the cubed root of 8. To do that, I'm going to need to multiply 2 times 4 will give me 8. So the cubed root of 4. And remember, whatever I do to the top or the bottom, I have to do the top. So that's going to leave me with the cubed root of 4 over the cubed root of 8. And the cubed root of 8 simplifies to a 2. And again, it's okay to have a radical in your numerator. So we have the cubed root of 4 on the top, and that's all we can do. So that's our final answer. For the next one, again, it's one fraction, but you want to go ahead and make it into, or one big radical, make it into 2 radicals. So we have the cubed root of 3x over the cubed root of 4. And again, 4, to get rid of it, we're going to turn it into 8. So this time we're going to multiply both top and the bottom by the cubed root of 2. So then on the bottom, I'll have the cubed root of 8. And on the top, I'll have the cubed root of 3 times 2 is 6. So it'll be the cubed root of 6x. To simplify, again, the cubed root of 8 is 2. And then on the top, there's really nothing that we can do with that 6x. There's no perfect cube I can pull out of it, so that is my final answer. Okay, for F, our final example here, we are going to again split it into 2 radicals. So we have the cubed root of 5y over the cubed root of 3x squared. And then here, I need to figure out what perfect cube I can use if I have 3, and then I have x squared, so I need to turn that into a single x. Okay, so what we're going to do is 8 won't work, but 27 will. So I can multiply this bottom. 3 times 9 will give me 27. So I'm going to multiply times the cubed root of 9. And then I also need to turn x squared into x cubed. So I need another x. Again, whatever I do to the bottom, I have to do to the top. Okay, so on the top, I'm going to end up with the cubed root of 45 xy over the cubed root of 27 x cubed. And then when I simplify, On the bottom, I will have 3x. And on the top, there's really nothing that I can pull out of it. So it's just going to be the cubed root of 45xy. And that's our final answer. Okay, here we are going to work on rationalizing the denominator when we have two terms. And in this case, what we need to do is we have to multiply by the conjugate of our denominator when we have those two terms. The conjugate is simply the same expression, except in this case, because we have addition, we're going to write it with subtraction. So we're going to have the same two terms in our binomial, but the opposite sign. So I'm going to write it over here. Our conjugate for the square root of x plus the square root of y would be the square root of x minus the square root of y. So again, the same two terms, you just do the opposite sign. And remember, whatever we do to the top or the bottom, we have to do to the top. So what we're going to do here when we multiply, we have to remember to FOIL. So on the top, I'm just going to be left with, it's really easy, I'll distribute. We'll get 4 square root x minus 4 square root y. And then on the bottom, when I do my first terms, the square root of x times the square root of x is the square root of x squared. And then we'll do our outer terms. So we get minus the square root of xy. Next, we do our inner terms. So we will get plus the square root of xy. And then finally, we do our last terms. So the square root of y times the square root of y, and it's one positive, one negative, so it'll be minus square root of y squared. Then we want to simplify. On the top, there's really nothing we can do other than just rewrite it, because they're not like terms, we can't combine them. On the bottom, the square root of x squared is x. Now, if you look at the middle two terms, it's a negative square root xy and a positive square root xy. So they cancel each other out. They equal 0. So we don't have to worry about those. And then minus the square root of y squared is y. And if you notice, our denominator no longer has any radicals, so we are done with that problem. We can't simplify any further. All right, let's take a look at B with some numbers in here. And again, we have two terms in our denominator, so we're going to use our conjugate of the binomial on the bottom. So we're going to multiply everything by 2, and instead of minus the square root of 7, it will be plus the square root of 7. Again, whatever you do to the bottom, you do to the top. On the top, I'm just going to distribute the 6. I will get 12 plus 6 square root 7. And then on the bottom, we're going to FOIL. First terms, 2 times 2 is 4. Outer terms, 2 times the square root of 7 will give me 2 square root 7. Inner terms, negative square root 7 times 2 will give me a negative 2 square root 7. And then my last terms, a negative square root 7 plus a positive square root 7 will give me a negative square root of 49. Okay, when we simplify, on the top, they're not like terms. I can't do anything other than just rewrite it. On the bottom, we have our 4. Then remember, our middle two terms. Look, I have a positive 2 square root 7 and a negative 2 square root 7. They cancel out. The square root of 49 is 7. So we have 4 minus 7. And then when I further simplify that, we'll have 12 plus 6 square root 7 over 4 minus 7 is a negative 3. And then we could stop here, but there is some simplifying that we can do. And that simplifying really is going to come from factoring that top. We distributed at the top. We didn't need to. If I rewrite it as 6 times 2 plus the square root of 7 over negative 3, negative 3 divides into that 6, and it goes in there 2 times. So my final answer is going to be a negative 2 times 2 plus the square root of 7. So we were able to simplify it all the way and get rid of that denominator altogether. Okay, we're continuing to rationalize our denominator with 2 terms in the bottom. Here, my term on the bottom, or my expression, is the square root of 7 minus 4. So I'm going to multiply it by the square root of 7 plus 4. Okay, and for this one, what we're going to do is I'm going to leave the top alone for right now because I think we'll be able to simplify in the end. And if you want to, without distributing, you don't always have to distribute at the top. I would leave it in factored form to see if you can simplify first. Now, on the bottom, we're going to FOIL. So the square root of 7 times the square root of 7 gives me the square root of 49. And if you're getting good by now, you recognize that that's going to simplify to a 7. So you don't have to write out that step. You can write your 40 or your 7 there. If I do my outer terms, I'm going to get plus 4 square root 7. My inner terms will give me minus 4 square root 7. And my last 2 terms, negative 4 times positive 4, will give me a negative 16. When I go to simplify, we have 3 times, erase that real quick, 3 times the square root of 7 plus 4. And then the square root of 49 is 7. My middle terms, again, a positive 4 square root 7, negative 4 square root 7, they cancel out. So we have 7 minus 16, and that will simplify to a negative 9. And if you notice, since I didn't distribute, the 3 and the 9 can be simplified. So it's going to become square root of 7 plus 4 over a negative 3, because I divided them both by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. All right, and we're going to take a look now at our last example in this section. And we are going to multiply times our conjugate of our bottom. So we're going to multiply by 2 square root x minus the square root of y. Whatever we do to the bottom, we do to the top. Okay, this one's going to be a little bit more involved. So let's see here. On the top, we are going to need to FOIL here because we have 2 binomials. So when I multiply the top, I'm going to get 2 times the square root of x squared when I do my first terms, minus the square root of xy when I do my outer terms. My inner terms will give me 2 square root x, and my last terms will give me the square root of y. And honestly, right now, other than simplifying the 2 square root x, there's nothing I can do. So I'm going to go ahead and simplify that. I'm just going to erase it for space. The square root of x squared is x, so this term becomes 2x. Okay, when I simplify on the bottom, again, I'm going to FOIL. So 2x squared, or 2 square root x times 2 square root x will give me 4 square root x squared. Then I do my outer terms minus 2 square root xy, inner plus 2 square root xy. And then my last terms will be minus square root of y squared. Again, notice those middle terms cancel out. The square root of x squared is x, so we're going to have 4x. The square root of y squared is y minus y on the bottom. And then on the top, we said before we can't do anything, so we're just going to rewrite it. 2x minus the square root of xy plus 2 square root x minus the square root of y. And that is simplified as much as we can by rationalizing our denominator, and we are done. Okay, here we are going to solve radical equations. And a radical equation is any equation containing one or more radical expressions. To solve a radical equation, you must do the following steps. You have to isolate the radical to one side of the equation, raise each side to the power of the index. So if it's a square root, raise it to the second power. If it's a cubed root, raise it to the third power, and so forth. Then you're going to simplify and solve. And the last thing that you need to do is check the solutions or solution that you get and make sure that it works in the original equation. Because sometimes when you raise it to a power, you'll get more than one solution, and not all of them will work underneath the radical. So we're going to start off. First thing we need to do is isolate that radical. So for the first one, I need to move, let's start with the 8. We'll move that. So they subtracted it, so I'm going to add it to both sides, which will give me 2 times the cubed root, or the square root of 3x minus 1 equals 18. And then I still have that 2 there outside the radical, so I'm going to divide by 2 to get rid of that. And it's going to give me the square root of 3x minus 1 equals 9. Now that my radical is all by itself, I need to get rid of the radical. The way to undo a square root is to square. So I'm going to square this side to get rid of the radical, but whatever I do to one side, I have to do to the other, so I'll square the other side as well. If you square the square root of 3x minus 1, you get 3x minus 1. So you get what's under the radical, it removes the radical, and 9 times 9 is 81. So then we're going to solve the equation just like we would any other linear equation. I'll add 1 to both sides. And I get 3x equals 82. And then we'll divide by 3. So x equals 82 over 3. So we're done solving. I'm not going to simplify it into a decimal. I'm not going to, 82 thirds as a fraction is simplified as much as it can be. So I'm going to leave it as is, and I'm going to use it to check and make sure that it's not an extraneous root. So what I'm going to do is take a second if you want. Make sure you have the equation written down. And I'm going to erase the work so that I have room to do the checking. Let me erase really quickly. All right, and if you recall, our answer was x equals 82 over 3. So when I plug it into my equation, or substitute it into my equation, I would have 2 times the square root of 3 times 82 over 3 minus 1 minus 8 equals 10. Here, under the radical first, my 3's, if I were to multiply, would cancel each other out. They would equal to 1. So I'm left with 2 times the square root of 82 minus 1, which is 81, minus 8 equals 10. Square root of 81 is 9. 2 times 9 minus 8 equals 10 is what I have now. 2 times 9 is 18. 18 minus 8 equals 10. And then 18 minus 8 is 10. 10 equals 10. So our solution was a solution to the equation we solved, and it also works in the original problem. So that is our answer to the problem. All right, let's take a look at the next one. This one's a cubed root. And again, I have to isolate the radical. So the first thing I'm going to do is move that 4, which is not under the radical, to the other side. So now I have the cubed root of 6 minus 2x is equal to a negative 4. And what we want to do here is, this time it's not a square root, it's a cubed root. So to solve it, I'm going to raise everything to the third power. When you raise a cubed root to the third power, it takes away the radical, it gives you just what's underneath there. So we have 6 minus 2x equals, and negative 4 cubed is going to be negative 4 times negative 4 times negative 4, which is negative 64. And now we're going to solve our equation. So first, get rid of the 6. It's a positive 6, so we'll subtract 6 from both sides, which leaves me with negative 2x equals negative 70. Divide by negative 2. So we get x equals 35. And then from there, again, we are going to plug this into our original problem to see if it works. So let me see if I can. I'm going to erase again. I need the space. So pause if you want to write down the work. All right. All right, so we had x equals 35. And we want to make sure that it works. So we have the cubed root of 6 minus 2, and in this case times 35, plus 4 equals 0. We have the cubed root of 6 minus 2 times 35 is 70, plus 4 equals 0. The 6 minus 70 is going to give me the cubed root of negative 64, plus 4 equals 0. The cubed root of negative 64 is negative 4 plus 4. And when we add them, both sides are the same. So that solution is, in fact, a solution to our original problem. It works. All right, here we're going to solve an equation to the 4th power, or to the 4th root. So what we need to do is first, again, isolate that radical. We're going to subtract 5 from both sides. And that'll leave us with the opposite of the 4th root of 7x plus 1 is equal to a negative 2. And then it looks like the radical's all by itself, but we do have that negative there. Remember, that's like a negative 1. So let's divide both sides by a negative 1 to get rid of that. So now we have the 4th root of 7x plus 1. It's going to be equal to 2, because our negative 1s will equal a positive 1, and the 2 negatives give us a positive 2. Now we have the isolated radical. We want to get rid of it. It's the 4th. The index is 4, so we'll raise everything to a power of 4. And that cancels out the radical, so we have 7x plus 1, and 2 to the 4th power is 16. Now we're going to solve our equation. So we will subtract 1 from both sides. We get 7x equals 15. Divide by 7. So x equals 15 sevenths. And again, it's an improper fraction, but it's in simplest form, and seven doesn't go into 15 evenly, so we're going to leave it as is. And then again, the next thing you want to do is check in the original equation. If we check this, it does work, so that one is a good answer. Okay, next we have D, and to isolate the radical here, we need to add 1 to both sides. So we will end up with the square root of x squared minus 5x equals 6. And now we have the radical all by itself. And don't try to, a lot of people see the x squared, they're like, oh, I can just simplify that, get it out of the radical, but it's part of an expression. It's x squared minus 5x. So we can't just take the square root. We want to eliminate the radical by squaring both sides. So that will leave me with x squared minus 5x equals 36. And here, unlike the other equations we've done where they were linear equations, this is a quadratic equation. So we have to set it equal to 0 and factor to solve. So I'm going to subtract 36 from both sides. So I have x squared minus 5x minus 36 equals 0. And now we have to factor. So we're going to turn it into two binomials. I know that I have two negative signs, so within my factoring, I'm going to have one positive, one negative. I need two factors that multiply together to give me 36 that also add to a negative 5. And I know that 9 and 4, when multiplied, give me 36, and they can also add to give me a negative 5. So that means I need a positive 4 and a negative 9 are equal to 0. So now I'm going to set those equations equal to 0 themselves and solve. So I'll subtract 4 from both sides here, and I get x equals negative 4. I'll add 9 to both sides here. I get x equals 9. So my two solutions here are x equals negative 4 and 9. And again, you do want to check. I'm going to check and show you. Let's do negative 4. So we'll have the square root of negative 4 squared minus 5 times negative 4 minus 1 equals 5. Negative 4 squared is 16. Negative 5 times negative 4 gives me positive 20. Minus 1 equals 5. 16 plus 20 is 36. Square root of 36 is 6. 6 minus 1 equals 5. We have 5 equals 5. And that is correct. Okay, what I'm going to do now is, again, if you want to write down this, what we have so far, I'm going to erase so that I can show you that 9 works. And I'll just erase over here. Do that, and erase. If it'll let me erase. Alright, it won't let me erase for some reason. If I can erase over here. No. Alright, well, it won't let me erase, so I will tell you that 9 does work when you plug it in, so try it for yourself and see if you can make it work. Alright, here we're going to solve two more equations. And the first one, we have the x over here that we need to move to the other side. So I'll subtract x from both sides. And I get the square root of 2x minus 3 equals 3 minus x. And now our radical is isolated, so what we have to do is square both sides. In this case, when we square the first side, we'll be left with 2x minus 3. Do square root, you get the center of the radical. But here, I have to FOIL my 3 minus x. So I'm going to be left with 2x minus 3 over here. And then when I FOIL, I am going to get 9 minus 3x minus 3x plus x squared. And I'm going to simplify, and I'm going to put it in descending order. So I'm going to have 2x minus 3 equals x squared minus 6x plus 9. So I just rearranged it a little bit. And now what we need to do is, it's a quadratic again, so set it equal to 0. I'm going to move the 2x minus 3 to the other side, so I'll start by adding 3 to both sides. And then I'll also subtract 2x, since we're running out of room. Making sure to combine like terms. I'm going to move over here. That's going to give us x squared minus 8x plus 12 is equal to 0. Again, I have to factor it here because I have a minus and a plus in that order. My two signs are going to be negatives. I need a negative 8 in the middle, and I need two factors that multiply to give me 12 that will also add to give me a negative 8. And for 12, 2 and 6 work, and that will also add to give me a negative 8. Oops. Fix that. So I'm going to set them equal to 0. So x minus 2 equals 0, and x minus 6 equals 0. When I solve them, I'll add 2 to both sides, and here I'll add 6 to both sides. So I get x equals 6, and I get x equals 2. Now I do need to go back and check my solutions. So when I do this, I'm going to, let's see, I'm going to erase over here. So write down any information that you need. Okay, let's check the 2 first. So if I plug it in, we'll do 2 times 2 minus 3 plus 2 equals 3. 2 times 2 is 4. 4 minus 3 is 1. So the square root of 1 plus 2 equals 3. Square root of 1 is 1. 1 plus 2 equals 3. So 3 equals 3. It works. All right, now let's try 6. So I'm going to erase this one. Excuse me. And we'll do 2 times 6 minus 3 plus 6 equals 3. 2 times 6 is 12. 12 minus 3 is 9. So the square root of 9 plus 6 equals 3, plus 6 equals 3. The square root of 9 is 3. 3 plus 6 is 9. It does not equal 3. So in this case, we actually have two answers when we solve the equation, x equals 2 and x equals 6. But 6 is what we call that extraneous root. It doesn't work. So we would include it in our solutions. We would say our solution is x equals 2. That is our only solution here. And then that is why it's important to always check your answers, because sometimes one will work and the other won't, or sometimes none of them work. And if none of them work, you would say your solution is no real numbers. There is no solution. Okay, let's work on F now. And the first thing we're going to do is add 3x to both sides. So I'm going to have, and I'm going to move over here for space, we're going to have the square root of 16x minus 3 is now equal to 4x. And again, to unsquare square root, or to remove the radical, you square it. You square a square root, you get what's under the radical, so 16x minus 3 equals 16x squared. So we have another quadratic here. What I'm going to do is I want to keep the 16x squared positive, so I'm going to move the other stuff to the other side. So I'll subtract 16x and add 3 to both sides. And that will leave me with 0 equals 16x squared minus 16x plus 3. Okay, we have to factor this. And when we factor it, we are going to get 4x minus 3 times 4x minus 1 equals 0. And to take each expression, or each binomial, and set it equal to 0. So 4x minus 3 equals 0, and 4x minus 1 equals 0. Add 3 to both sides here. 4x equals 3. Divide by 4. X equals 3/4. Here we'll add 1 to both sides. So we get 4x equals 1. Divide by 4. So x equals 1/4. And then you would want to check both of these, and they do both work. So go ahead and check them yourself to see and confirm that. Okay, here we're going to use our Pythagorean theorem to find the missing part of the triangle. Remember, your Pythagorean theorem is a squared plus b squared equals c squared. Or if you take each leg of a right triangle and square it and add them together, it will equal the hypotenuse squared. Now remember, your legs are what make up the right angle in the right triangle. So here is a leg, here is a leg. Doesn't matter what you call A or B. I'll make that one A, I'll make that one B. And your hypotenuse is always the side that is opposite the right angle. It's always the longest side. So to find here, I want to find the hypotenuse. I want to find C. So I'm going to plug in or substitute in my values for A and B into the Pythagorean theorem and solve. So we're going to do 5.2 squared plus 11.6 squared is equal to C squared. All right, when I square 5.2, I do 5.2 squared. I get 27 400 plus, and then 11.6 squared is 134 5600. That equals C squared. If I add the two together, I get 161 6/10 equals C squared. Now, this is good, but I need not C squared, but C. So what I have to do to unsquare something, take your square root. So we'll take the square root of both sides. The square root of C squared is C. And the square root of 161 6/10. And they want us to round to 2 decimal places, will be 12 71/100. Okay, now that's an approximate answer, only because, remember, 161 6/10 is not a perfect square, so it's going to be an irrational number or decimal that goes on infinitely. So we're just going to round our answer. So really, here we could put like the approximately equal to. So the hypotenuse is approximately 12 71/100 inches here. Let's take a look at our second problem. This time, if you notice, here's my right angle. Okay, here are my two legs. And here is my hypotenuse. We are missing a leg this time. So when we plug our values into our formula or substitute them in, I'm going to have x squared, because I want to square a, which is x, plus 5 squared is equal to, and c this time is 13 squared. So I'll have x squared plus 25 equals 169. And now really what I need to do is solve for x. What we're going to do is isolate the x squared. So we'll subtract 25 from both sides. When I do that, I get x squared is equal to 144. And now we need x, not x squared. So to unsquare, take the square root of both sides, and we get x equals 12. So here, the leg is 12, and that would be our final answer. Here we're looking at applications of right triangles. The best thing to do here is to help solve it is to draw a picture. So we have a ladder that is 17 feet long, and it leans against a wall. So I'm going to draw, here's my wall. Okay, my ladder is 17 feet long. So here is my ladder. And if you think about a ladder, when it leans against the wall, it doesn't lean straight up. It leans at an angle. And then we'll put the ground down here. So if you notice, I made a right triangle here. And we know that the ladder is 17 feet long. And the height from the base of the wall to the top of the ladder is 15 feet. So here's the base of the wall, and here's the top of the ladder. This distance right here is 15 feet. And they want to know, what is the distance from the base of the wall to the bottom of the ladder? So right here, this is x. And remember, where our wall meets the floor, that's going to be a 90-degree angle. So again, this time we're missing one of the legs, and we have the hypotenuse. So we're going to solve it again. We're going to do x squared plus 15 squared is equal to 17 squared, or x squared plus 225 is equal to 289. And we'll subtract our 225 from each side. And we get x equals 64, or x squared, excuse me. And again, to unsquare something, you take the square root. We'll take the square root of both sides, and we get x equals 8. So the ladder is 8 feet from the wall. All right, our second one. This time we have a satellite tower that has a guy wire attached to it to stabilize it from wind and rain. So remember, you have those, see those tall cell phone towers, they always have the wires attached to them to help stabilize it because they get pretty tall and unstable. So we have, here's our tower. And then here is the wire attached to it, and it goes down to the ground. Pardon my drawing skills. Here's our right angle. All right, so the guy wire is half a mile long. So I'm going to say, we're going to do 0.5, half a mile. And is placed 327 thousandths miles from the base of the tower. So 0.327. Find the height of a tower in both miles and feet. Recall there are 5,280 feet in 1 mile. So we're starting off here in miles. And we have, again, hypotenuse here and a leg. So we're going to need to find the height of the tower. So we're going to do x squared plus 327 thousandths squared equals 5/10 squared. Okay, so we have x squared. When I square 327 thousandths, I get decimal points 1.06929, and it equals 25 hundredths. Then we'll subtract from both sides. And I get x squared is equal to decimal point 143071. And again, to undo it, you take the square root. So I get x equals 39 hundredths miles. And the last thing we need to do is convert it to feet. So I know that 1 mile equals 5,280 feet. And we have 39 hundredths of a mile. I'm going to set up a proportion here. Cross multiply. So we'll get 1 mile times x is x. And if we do 5,280 times 39 hundredths, we get 2,059.2 feet. Okay, so here we're going to use our distance formula to find the distance between two ordered pairs. They give us the formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. Our first two ordered pairs are 0, 3 and 3, 7. So what we're going to do is just simply plug in our values into our ordered pairs, or our formula, and you can label them like this is x1, y1, x2, y2, just to help you put them into the formula. So we have 3 minus 0 squared plus 7 minus 3 squared. And then we'll do our math underneath the radical first. 3 minus 0 is 3, so we have 3 squared plus 7 minus 3 is 4. We have 4 squared. So that if we square them, we get 9 plus 16, which you add them, you get 25, and the square root of 25 is 5. Now our directions say to give the exact and an approximate answer to 2 decimal places if necessary, but we have a perfect square, so our answer is 5. Okay, for the second one, again, let me go ahead and label. We have x1, y1, x2, y2. And I'm just labeling these. It doesn't matter which one you call x1 and y1 as long as they're together in the ordered pair, and then y2 and x2. I could have made this right here, x2, y2. Doesn't really matter as long as, again, you're consistent. So we're going to do 1 minus, let me fix that. Okay. So it is 1 minus a negative 10. And you got to be careful with those signs. Make sure you include the correct signs. Plus, and then we have 50 minus, because that's part of the equation, and then a negative 10 squared. So 1 minus a negative 10, remember addition of the opposite plus a positive. So it becomes 11 squared plus 50 minus a negative 10, addition of the opposite becomes 60 squared. So when I square 11 squared, I get 121, and 60 squared, let me do this real quick, it's 3,600. Add those two together, and we get 3,721. And when I take the square root of that, it is another perfect square. It gives me 61. So the space between those two ordered pairs is 61 units. And that's all. All right, here we're going to use other applications in geometry. We have a sphere, and they've given us two formulas. The first one is how to find the radius given the surface area, and the second one is how to find the radius given the volume. So first we're going to find the radius given that the surface area is 3 7/10 centimeters squared. All I'm going to do is plug that into my formula. So I have the radius is equal to and it's going to be the square root of the surface area, so in our case 3.7, divided by 4 pi. And then we're going to do the math. We're going to work under the radical first. That's like our parentheses. So what I'm going to do is multiply 4 times pi, and I'm going to do 4 times 3.14. It just makes life a little bit easier instead of using the pi button on the calculator. So it's going to give me 3.7 divided by 12 and 56 hundredths. And again, we're approximating, so it's okay to use the 3.14. Now on my math lab, they may have you use the whole thing. 3.7 divided by 12.56. Okay, when I do this, I get the square root of, I'm going to round to the 10,000, so we have 2,946 10,000ths. And when we take the square root of that, and I round my answer to 2 decimal places, I get 54 hundredths centimeters. So that would be my radius. For the next one, we're going to find the radius given the volume. So I'm going to use the second formula. And here, I have to find the cubed root of 3 times the volume, and my volume is 6.1, because that's what they gave me, all divided by 4 pi. So again, from the other problem, we know that 4 pi, when we use 3.14, is 12 and 56 hundredths. When I do 3 times 6.1, I get 18 and 3/10. Okay. And then again, I'm going to continue until I have a single number under that radical. So 18 and 3/10 divided by 12 and 56 hundredths will give me 1 and 457 thousandths. And I cut it off there instead of going out 4 places, only because I had zeros after the 7, 2 zeros, and then some numbers. And then I'm going to take the cubed root of those. So the cubed root of 1 and 457 thousandths is equal to 1, and I asked us to round to 2 decimal places, so 13 hundredths inches. All right, here they give us a cone and they give us 2 formulas. The first one is how to find the radius of the cone given the volume and the height. And then the second formula is how to find the surface area given the radius and the height. So we're going to take a look at A. They give us the volume and the height, and they want us to find the radius. So we use our first formula, and we have R equals the square root of 3 times the volume, which is 12.9, over pi, and again, I'm going to use 3.14, times the height, which is 3.7. So I'm going to do the math under the radical. First, I'm going to do 3 times 12.9, and that gives me 38 and 7/10. And on the bottom, 3.14 times 3.7 gives me 11 and 618 thousandths. All right, when I divide those two, I get, and I'm going to round it to the thousandths, 3 and 331 thousandths. And then I take the square root of that. And my final answer is 1 And they want it to 2 decimal places, so 1 83/100, and it will be kilometers. For the second one, they want us to find the surface area given the radius is 3.9 yards and the height is 5.7. So I'm going to use the surface area formula. And we're going to do pi, so 3.14 times the radius, which is 3.9, times the square root of the radius squared, so 3.9 squared plus the height squared, which is 5.7. Okay, so let's do 3.14 times 3.9 to simplify the outside. And we get 12 and 246 thousandths times. Now, underneath the radical, if I do 3.9 squared plus 5.7 squared, I get 47 and 7/10. Then I have to take the square root of that. So I get 12 and 246 thousandths times, and I'm going to round it to the thousandths right now. 6 and 907 thousandths, and when I multiply that together, my final answer rounded to 2 decimal places is 84 and 58/100 yards. Any questions? Here we have our last slide for this section, and here's where we're going to find the area of any triangle. When we know the side lengths, we don't necessarily know the height and the base, which is what we need to find the area using our 1/2 height times base. But if we know all 3 side lengths, we can use Heron's formula to find the area of the triangle. The formula is A, or the area, equals the square root of the S times S minus A times S minus B times S minus C, where S is half of the perimeter. So the first thing we have to do to just solve this is find S each time. So what you're going to do, your perimeter, remember, is when you add up all your sides. So for this first one, to find S, I'm going to add 10 plus 26 plus 24 and divide it by 2. So when I add 10 plus 26 plus 24, it gives me 60. 60 divided by 2 will give me 30. So S in this problem equals 30. And then I'm going to use it in the formula. A, B, and C are the sides of the triangles. So I'm going to do, it's going to get kind of long, 30 times 30 minus 10, 30 minus 26, and 30 minus 24, which is going to give me 30 times 20 times 4 and times 6. And when we do the math underneath the radical, let's see, 30 times 20 times 4 times 6, which is 24. I will get 14,400. And then I'll take the square root of that. And I get 120. So the area is 120. And since we don't have any units, it'll be units squared. Okay, now for the second one, there is a mistake on there. Make that 1 underneath. It won't work with 1. It has to be an 11. So just add that in on your paper. And again, the first thing we want to do is find S. So S is going to equal 15 plus 16 plus 11 divided by 2. And we get 42 divided by 2. So we get 21 for S. So then when I plug it into my formula, I'm going to have the square root of 21 times 21 minus 15, 21 minus 16, and 21 minus 11, which will give me 21 times 6 times 5, and then times 10. 6 times 5 is 30, and then 30 times 10 is 300, and times 21 give me 6,300. So A equals the square root of 6,300. Take the square root of that, and we get A equals, and we'll round it to 2 decimal places because it's not a perfect square. So we have 79 and 37 hundredths. And again, it's area, so it will be units